Hello, hi, good morning dear students. How are you all? This video lesson module number 7 on periodic classification of elements brought to you by Vignan-Vidyalaya's. I, myself, Reddy.P, teaching faculty, Vignan-Madinaguda, Hyderabad. Dear students, in the previous module, we have already learnt about periodic properties, how they will vary in a group from top to bottom, like atomic size, valency electrons, valency, metallic character, non-metallic character, nature of the oxides. By taking the example of group, I beautifully explained all the 6 properties and the trends observed, along with the reasons also. We learned already. Good. Now, today, the same 6 periodic properties, let me take, and I will explain the trend or the variation observed in a period from left to right side. That means how these properties would vary while moving from left to right side in any period. So, without delay, shall I start the lesson? Shall I start the topic? So, all of you to observe very carefully. This topic is very, very important for the examination point of view. Please stay tuned about the board and try to remember systematically. And later try to work out various questions in the form of question paper attached. Okay? Okay, my dear students? Yes, let me start. Anyhow, this topic also comes under the same topic. What is that main topic? Trends in the modern periodic table. But this time, periods. Yes. First of all, let me ask a question. What is period in the modern periodic table? What are periods? You are correct. Periods are horizontal rows. Horizontal rows of the periodic table. Every horizontal row has 2 ends. One is left end, second one is a right end. Okay, just observe and remember this information. Now, how many periods are there in modern periodic table? There are 7 periods. Out of these 7 periods, let me take one example. Now, according to me, let me select period number 2. Because first period contains only 2 elements. That's why I don't prefer that one. Let me prefer period number 2. So, I am taking the example. What is that example? Beautiful example for period. Period number 2 from modern periodic table. Now, every period consisting of left end as well as right end. Okay, na? Right end. I am now drawing that horizontal line. Yes. Left end, right end, horizontal row. What is that period number 2? Now, let me write different elements. What is the first element in the period number 2? You know? Lithium. Good. Next, after lithium, after beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Yes. So, neon symbol Ne. Okay, now don't get confusion. Neon symbol Ne. Now, let me explain this group. In this group, overall, how many elements are there? 8. Out of these 8 elements, first, lithium is a metal. Okay. And what about beryllium? Beryllium also metal. What about boron? Boron is a metalloid. My dear students, do you know what are metalloids from chapter number 2 of 9th-Cbse chemistry? What are metalloids? These are the elements whose properties lies between that of metals and non-metals. Means metalloids possess intermediate properties, some properties of metals and some properties of non-metals. In the modern periodic table, these metalloids are in the form of a zigzag line which separates metals from non-metals. Now coming to boron, boron is a first metalloid. After silicon, other metalloids also there, but boron is the first metalloid. What about carbon? It's a pure non-metal. Nitrogen, non-metal. Oxygen, non-metal. Fluorine, non-metal. Even neon also non-metal. But neon is called noble gas and group number 18 belongs to. So this is about period introduction, second period. So in second period, there are 2 metals, 1 metalloid and 5 non-metals. Now one by one, I will give the information. First, atomic number. Let me write. Atomic number is denoted by the symbol Z, no? Lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10. See, atomic number increases 1 unit regularly. So 3, 4, 5 like that. And next, electronic configuration. Let me write 2, 1 Kl, 2, 2 Kl, 2, 3 Kl, 2, 4 Kl, 2, 5 Kl, 2, 6 Kl, 2, 7 Kl, 2, 8 Kl. Whether you observed or not, number of valency electrons are increasing in regular manner, but the number of shells remain same. Okay? And now next, valence electrons. Count. Lithium consisting of 1, beryllium 2 valence electron, boron 3, 4, 5, 6, 7, 8. So valence electrons are increasing in regular manner. What about valency? Lithium ka valency 1, beryllium 2, boron valency 3, carbon tetravalent. Carbon is tetravalent. Now nitrogen, the valency of nitrogen is 3. Why it is not 5? Why it is 3? Because already 5 valence electrons are there in nitrogen. Still 3 more electrons required to attain stability. So that's why the valency of nitrogen is 3. And do you know what is the valency of oxygen? 2. Because already 6 valence electrons are there, still required 2. Fluorine, already 7 valence electrons are there, just required 1. That's why valency is 1. But neon, the valency is 0. Why for neon the valency is 0? Because there is no combining capacity in the case of neon. Why there is no combining capacity? Because neon already consisting of 8 electrons octet in the outermost shell. They do not react with the other elements. Okay. So this is about the preliminary information about second period in the modern periodic table. Now let me draw one table to illustrate this information in a neat manner. Okay. In the form of a table. Now this table consisting of first column is meant for property. That you know very well, all the 6 periodic properties. Now trend observed in a period, and now reason, specific reason if any. Are you ready for this one? This is very important for examination point of view. Please concentrate properly, everyone. Now coming to first periodic property, valence electrons. Now every period consisting of two ends, left to right, how these valence electrons vary from left to right side. Now this is about valence electrons. Lithium 1, beryllium 2, boron 3, carbon 4, nitrogen 5, oxygen 6, fluorine 7, neon 8. So what is the trend observed here? Yes, you are correct. Regularly increases. So valence electrons increases regularly from 1 to 8. Okay. So whenever valence electrons increases, automatically that influences valency. In what way valence influences? Let me see. Now, what is the reason why valence electrons increases? Because each and every period consisting of elements of different groups. Elements of different group possess different valency electrons. That's why there is a variation in the valency electrons. Now coming to valency. How the valency vary from left to right side? See, the valency of lithium is 1, beryllium 2, boron 3, carbon 4. But after carbon, the valency again decreases, nitrogen 3, oxygen 2, fluorine 1 and becomes 0 at noble gas. So what is the trend observed here? Valency do not follow in a regular manner, do not increase in a regular manner. So valency first increases 1 to 4 and then decreases from 4 to 0. So what is the reason for that? The reason might have depends or explained on the basis of valency electrons. Whenever the valence electrons increases, that even affect valency of the corresponding elements. So valency always depends on valency electrons. Now coming to atomic size. AS stands for atomic size. Atomic size is also called atomic radius. How it will vary? Let me see. Now you try to answer to my questions first of all while dealing this atomic size. From left to right side, atomic number gradually what? Increases. Good. If atomic number gradually increases, proton number present in the nucleus also increases. Yes or no? If proton number increases, nuclear charge also increases. But still the number of shells are remains same. 2 shells just KL. Valence electrons increasing, protons increasing, nuclear charge increasing, but still number of shells not increasing, remains same. Now if it is the case, due to increase in nuclear charge, once again, due to increase in nuclear charge over outermost shell electrons, those outermost shell electrons tend to pull towards nucleus. That's why atomic size in a period from left to right side decreases. Got my point? So simply atomic size decreases from left to right side. What is the reason? Can anybody tell exact reason for this? Why atomic size decreases from left to right side? Very simple explanation. Reason within just 2 sentences. Concentrate. Due to increase in nuclear charge over outermost shell electrons. Because of this, electrons are pulled towards the nucleus so that size of the atom slowly reduces. Orbit come closer to the nucleus. Because of this trend, automatically atomic size decreases. But if you compare halogens with noble gases, the atomic size of halogen is lesser compared with the noble gas. That means Noble gas atoms are consisting of big size compared with the fluorine. Little bit bigger noble gases. Why? Due to its stable electronic configuration. Due to their stable duplet or octet configurations, the size of the atom corresponding to noble gas is more compared with the halogens. You try to remember this point for future correspondence. Now coming to metallic character, MC. As I told in the beginning of this class, metals are located in the left side of the modern periodic table, where non-metals are located in the right side of the modern periodic table. And both metals and non-metals are separated by a zigzag line that is called metalloids. So, metalloids separate both metals and non-metals. This is also very important. Now, while moving from left to right side, in any period, metallic nature or metallic character gradually decreases and non-metallic character gradually increases. Why? Because the size of the atom becomes quite small, and when the size of the atom becomes small, nuclear attraction over outermost shell increases. Because of that, metallic character decreases from left to right side. And what about non-metallic character? Quite reverse. Non-metallic character in any period from left to right side increases. And this is one of the evidence. See, metals gradually decreasing, non-metals gradually increasing. That even depends on size of the atom. Since the size of the atom decreases, non-metallic character increases. So, non-metallic character increases from left to right side. And what is the last one? Nature of the oxides. Nature of oxides. Yes. How these nature of oxides vary across a period from left to right side? You know, lithium is able to form lithium oxide, which is basic in nature, and beryllium is able to form beryllium oxide, which is basic in nature, because these are two metals. But while moving from left to right side, basic nature of the oxides gradually decreases and the acidic nature of the oxides gradually increases. That trend observed. Once again, what is that? Basic nature of the oxides decreases, acidic nature of the oxides increases. Okay, and these are the 6 important periodic properties with respect to a period. This is my explanation, and this explanation is very simple if you concentrate properly. So, before going to end up this particular module, let me recapitulate once again. In any period, from left to right side, if you observe, valence electrons increases from 1 to 8 or increases gradually. And if you take valency increases 1 to 4 and then decreases to 0. And what about atomic size? Atomic size gradually decreases across a period from left to right side. I already told the reason. What is the reason? Due to increase in nuclear charge over outermost shell electrons, these electrons tend to pull towards the nucleus, so size of the atom reduces. And that is one of the reason why atomic size reduces or decreases in a period. Now coming to metallic character, because most of the metals are located at left side of the modern periodic table and non-metals are located right side of the periodic table. So while moving from left to right side, metallic character decreases and non-metallic character increases. And even this depends on atomic size indirectly or directly. Now coming to nature of the oxides. Since metals are able to form basic nature of the oxides, so basic nature of the oxides gradually decreases, and boron is able to form amphoteric oxide, and non-metals are able to form acidic oxide. So what is the trend observed here? Basic nature of the oxides decreases, acidic nature of the oxides increases. So my dear students, this is about trends in modern periodic table with respect to periods. All the trends means atomic properties or periodic properties, how they will vary in a period from left to right side. So everyone hope understood this particular proforma or module, which is very important from 10th-Cbse board examination point of view. My dear students, till then, so now all of you, so I am going to say thanks to everyone for all these modules on periodic classification of elements. So thank you one and all. Have a nice day. Thank you.